Hello everybody, this is Mr. McAvoy. We're going to do the first video for Algebra 1, Summer School 2020. This will be covering the 1.1.3 quiz, rational and irrational numbers. First thing we're going to talk about is the difference between what a rational number is and what an irrational number is. So I'm going to come over here and I'm going to start with rational. And you all will get very used to the fact that my handwriting is not very good, and that's okay. All right, so rational numbers. A rational number is any integer. Integer, that's a -4, 7, 72, etc. Whatever else. Any integer, whole number, however you want to call it, any integer. Doesn't matter if it's positive or negative. If it's an integer, it is a rational number. Any fraction. So anything that is written as a fraction is considered a rational number. It could be an improper, it could be negative, it doesn't matter. So anything that's written as a fraction. Let's see if I can't. All right. Any terminating decimal. Now, what a terminating decimal is a decimal that ends. So, a 0.4, a 6.32, a negative 22.654. Any of those are terminating decimals. That means they end. They don't go on forever. They don't repeat. They end. They go to a set number and stop. So a terminating decimal. And then a repeating decimal. Ooh. All right, 0.333. It could be 1, 2, 3, 1, 2, 3. It could be a pattern like this as long as it repeats. It could be a 0.166666 all the way around. All right, it could be that. So any pattern, anything that repeats. So it goes on forever with the same pattern each and every time. Those are all rational numbers. So if I am not an integer, a fraction, a terminating decimal, or a repeating decimal, I'm going to be an irrational number. So if I can't check any of these boxes, if I'm looking at examples, and that's what we can go through some examples here. Let's scroll. Let's just go right over here. We got orange. So we have 0.4. We'll have 3 pi. We'll have the square root of 9. We'll have 0.444 forever. And we'll have 2 7s. All right. So I'm going to look at these. Switch my color. Now, 0.4, is it an integer? No, it is not an integer. Is it a fraction? No, it is not a fraction. Is it a terminating decimal? Does it end? Absolutely, it ends. It stops. That is now a rational number because it is a terminating decimal. 3 pi. Now, I don't know exactly what 3 pi is, right? So, because that's a multiplication problem. So what I'll have to do is I'll actually have to do the math with it. I have to do 3 times pi. And what I'm going to get is a 9.424779961. It goes on forever. Is that number an integer? No, it is not an integer. Is it a fraction? It's not a fraction. Is it a terminating decimal? No, it doesn't end. Is it a repeating decimal? No, there is no pattern. So I went through all 4 of my options for a rational number. None of them apply to this, to 3 pi. That tells me that this problem right here, or this number, this 3 pi, is an irrational number. Square root of 9. So square roots are not within our little check here. So what I have to do is I have to take the square root of 9. Well, the square root of 9 is equal to 3. All right, so the square root of 9 is equal to 3. Is 3 an integer? Yeah, 3 is an integer. That means, yes, it is a rational number. 0.44444. Is it an integer? No. Is it a fraction? No. Is it a terminating decimal? No, it doesn't end. Is it a repeating decimal? Yes, it does. It repeats 4 each and every time. So this is a rational number. It is a repeating decimal. 2/7. Is it an integer? No, it's not. Is it a fraction? Well, yes, it is. It is a fraction. That means it is a rational number. So that's what I'm doing. I know my 4 things that make something a rational number, and I'm just going to apply it to whatever the number is. Now, like we had to do with the 3 pi and the square root of 9, we may have to actually calculate something. So we had to do 3 times pi to get the number, so we can actually compare to my list. We had to take the square root of 9 so I can compare to my list. So we may have to do that, which is fine. But with that, we're just going to look. Is it an integer? Is it a fraction? Is it a terminating decimal? Is it a repeating decimal? If you say no to all 4 of these, it's automatically an irrational number. All right, now, sorry, I'm scrolling on my other screen. Bear with me for just a second. Now, when we add, if I have a rational number and I want to add, excuse me, I want to add another rational number. So I have a rational number plus a rational number, whatever the numbers may be, it doesn't matter, just in general. If we're adding 2 rational numbers, my answer will be rational. If I am adding a irrational number to an irrational number, my answer will be irrational. If I'm adding an irrational number to a rational number, rational plus irrational, my answer will be irrational. So if I have 2 rational numbers, I know my answer is a rational number. If I have 2 irrational numbers, I know my answer is an irrational number. If I have a rational and an irrational, my answer will be irrational. Now, if we do multiplication, we have 2 rules for this, is if I have 2 rational numbers, if I have a rational number times a rational number, my answer will be rational. If I have a rational number and I multiply an irrational number, the answer will always be irrational. All right. So what this will look like on the quiz is they'll say what number must be added to, we'll say 0.7. So what number must be added to 0.7 to produce an irrational? Oh, sorry. So what number must be added to 0.7 to produce an irrational number? All right. Now, the first question I'm going to ask is, how do you produce an irrational number when we're talking about addition? All right. So if I go back over to my list over here, is we want to do addition, and we want to produce an irrational number. So that gives me these 2 scenarios right here. All right, I can have 2 irrational numbers will equal an irrational number, or 1 rational and 1 irrational gives us an irrational number. All right, so what we need to do is we need to identify what 0.7 is. So going back to our little list over here, is 0.7 an integer? No, it is not. Is it a fraction? No, it is not. Is it a terminating decimal? 0.7 is a terminating decimal. So we know that 0.7 is a rational number. All right, so we know that 0.7 is a rational number, and we want to add something to it to produce an irrational number. So we know we no longer need that. Oh, I got to undo that. I don't know what I just did. All right, so we're going to go ahead and get rid of this piece of it. Right? So we don't need the irrational anymore because we know our 0.7 is rational. So we are looking for an irrational number. Say I am given these 4 answers. All right, so these are my 4 answer choices. So I have 0.7, which is a rational number. I want to produce an irrational number. I know the answer I'm looking for must be irrational because I have a rational number plus an irrational number equals irrational. So I need to find an irrational number. Well, how am I going to do that? 1/3. Is it rational or irrational? Well, is it an integer? No. Is it a fraction? Yes. So it's rational. Square root of 3 we'll come back to. 0.555. Well, is it rational or irrational? Is it an integer? No. Is it a fraction? No. Is it a terminating decimal? No. Is it a repeating decimal? Well, yes, it is. That makes it rational. Now we need to, because we have a square root of 16 and a square root of 3, is I need to go ahead and do the square roots of both of those. So the square root of 3, the square root of 3 is going to be 1.7320500803, and it keeps going. All right, the square root of 16 is 4. Is 4 an integer? Yes, it is. That means this is rational. The square root of 3, is this an integer? No. Is it a fraction? No. Is it a terminating decimal? No. Is it a repeating decimal? No, it's not. So that means that square root of 3 is an irrational number. Now, since we were trying to produce an irrational number and we were given a rational, we knew our answer had to be irrational. I only have one option. In this case, it would be B, radical 3. So we need to be able to identify if a number is rational or irrational. We just ask, is it an integer, fraction, terminating decimal, repeating decimal? If any one of those is yes, we're good. We got a rational number. If all 4 are no, it's irrational. Then we're going to have these scenarios. They're going to ask us, well, we know that 2 rationals equal a rational when we add them. When we add 2 irrationals, it gets irrational. When we add a rational to an irrational, it equals irrational. And what they're going to, basically what the quiz is going to ask us is they're going to give us a number. This 0.7, we need to identify it as rational or irrational. All right, so once we identify that, we need to then find out what we want to get. So I want to add and I want to get an irrational number. That narrowed me down to these 2 options here. The number they gave me was rational, so that narrowed me down to just this bottom one in green. And then I go through the answers and find which one of the answers is going to be irrational because that's what I need. Now, the actual definition in Apex, just to cover, because I think there probably will be a quiz question on this, is that they'll use P and Q. They'll say a rational number is any number that can be written as P over Q, which is a fraction, right? Because an integer, terminating decimal, and repeating decimal can all be written as a fraction. So like the very basic level of this is a rational number is any number that can be written as a fraction, and then Apex will always use P over Q generally. So if they have a question like what type of number can be written as a fraction P over Q, well that's a rational number because it can be written as a fraction. And then we always have to remember that we can't divide by 0, so Q would have to be a non-zero integer. I'm going to take a quick review of the quiz to make sure I haven't missed anything. I think we have it. So again, quick review. We identify if a number is rational or irrational by going through our list. I then use these 3 sum guides, we'll call them. They're little guides to how we'll add rational, irrational numbers and what you produce. And then we have a couple for multiplication. As always, if you have any questions, need any help, please email us. Email myself, Mrs. Hoffman, Mrs. Thomas, Mrs. Tinsley. If it's after 12 p.m., you can call or text Mr. Allen. and we'll get you exactly what you need.